A system may go through a series of processes. A system is called a cycle if the final state ends at the initial state. So it may experience several states, but the final state returns to the initial state. So the net change in the property values for a cycle is 0. For example, consider a PV diagram. Y-axis P, pressure, x-axis V, volume. So initial state is 1, and it goes through state 2 and 3 and 4. So initial state 1, it moves to state 2, then state 3, then state 4, and we return back to initial state 1. So the initial state and the final state are the same. It is a thermodynamic cycle. For thermodynamic cycle, there is no net change in energy of the system. So delta E in the cycle is 0. So Q cycle equals W cycle. I will briefly introduce power cycles, refrigeration cycles, and heat pumps cycles. They will be discussed in depth later in the semester. So power cycles, refrigeration cycles, and heat pump cycles are energy conversion cycles. So power cycles is used to provide work during the cycle. And refrigeration cycles and heat pump cycles use work to transfer heat from a low temperature to a high temperature medium. They are essentially the same cycles. Refrigeration cycles and heat pump cycle, they are essentially the same cycle, but they are used for different objectives. Refrigeration cycle is to provide cooling. Heat pump cycle is to provide heating. The performance of power cycle is defined as thermal efficiency. Thermal efficiency is defined as the desired output over required input. So desired output. So power cycle provide work. So desired output is the W cycles, and required input, we need to provide heat. The performance of refrigeration cycles and heat pump cycles are defined as coefficient of performance. Coefficient of performance also expressed as desired output and required input. So coefficient of performance for refrigeration cycle is better. So desired output is Q in. Refrigeration cycle is to provide cooling. So we are interested in the cold body. How much heat is removed from the cold body? So coefficient of performance beta is Q in, desired output Q in, over how much work is required to move the heat from low temperature to high temperature. So required input W cycles. The performance of heat pump is coefficient of performance denoted by gamma. So desired output here is Q out. We are interested in this area, this space, to provide heat. Move the heat from low temperature to high temperature. So desired output is Q out, and work need to be done to move the heat from low temperature to high temperature. So coefficient of performance Q out over W cycle. So we learn about thermodynamic cycles more in depth later in the semester. So this concludes chapter 2.